this video, we'll talk about how to calculate the p-value. Find the p-value for the following. The test statistic in a left-tailed test is z equals negative 1.25. So remember, this is a z, so we're going to label the curve 0 as the mean, to the right 1 and 2, to the left negative 1 and negative 2. And z is negative 1.25. We're going to show that cutoff. Z equals negative 1.25. And how do we know if we shade to the left or the right? Well, what we can do, let me just adjust this here. What we can do, since it's a left-tailed test, we know that it's going to be a left tail. So we're going to shade to the left of z equals negative 1.25. This is the p-value. So now, on StatCrunch. On StatCrunch, we're going to find the probability of z being less than negative 1.25. And since this is a z distribution, we're going to use stat, and then calculators, and then we're going to go to normal. We did this in a previous chapter. Remember, our mean is 0 and our standard deviation is 1, and we just put in negative 1.25, and we hit compute, and our p-value is 0.1056 if I round it. So I label the p-value on the graph as 0.1056. That's the area on the left. It's also the p-value. The next one, with h sub a, p greater than 1/4, the test statistic is z equals 2.30. So I'm going to label my curve as 0, 1, and 2, and negative 1 and negative 2. Under my normal curve, z is 2.30, so I label that cutoff mark. And it doesn't say if it's a left-tailed or right-tailed, but it does give us our h sub a says p is greater than. And because if it's greater than, we know that this is going to be a right-tailed test. So I'm going to shade to the right of z equals 2.30. Now I'm going to go to StatCrunch and find the probability of z being greater than 2.30. On StatCrunch, I'm going to change the inequality to greater than, and I'm going to put here 2.30. I'm going to hit compute. So that p-value, that little tiny shaded area to the right, is 0.0107. And that will be our p-value. Our last problem says with h sub a, p is not equal to 0.70. The test statistic is z equals negative 2.95. Because it's not equal to, we know that this is going to be a two-tailed test. And when it's a two-tailed test, we're actually going to have the negative z value and the positive z value. So I'm going to add 2.95 on here. And under the curve, I'm going to put 0, 1, and 2, and 0, negative 1, and negative 2 here as my scale. So I'm going to go negative 2.95, label that as a test statistic, negative 2.95, and positive 2.95. And again, because it's two-tailed test, I'm going to shade to the left and to the right. To the left of negative 2.95 and to the right of 2.95. So when we do this on StatCrunch, there's a couple ways you can do this. I'm going to go ahead and choose to go 1 minus the probability of z being between negative 2.95 and positive 2.95. So let's go ahead and do that. On StatCrunch, in the normal distribution curve, I'm going to go ahead and select the in-between and change the first probability to negative 2.95 is less than or equal to x, which is less than or equal to, and I'm going to choose 2.95. So remember, that's the way we say in between. I hit compute, and that value is 0.9968. I'll just do 4 decimals for time's sake. And remember, we don't want the area in between, we want the area on the outsides. This means we have to go 1 minus that value. So let's see, 1 minus 0.9968 is going to be 0.0032. So the p-value in those two little outside areas is going to be very small. We knew that, 0.0032. And that's how you calculate value on the normal distribution, which is the z for the means. If you're doing it for the, I'm sorry, that was for the proportions with the z's. If you're doing it for the means with t's, you would use the t calculator. And if you're doing it for the chi-squareds, you would do it, or the standard deviations, you do the chi-squared distribution.